where we're going to be finishing up the chapter. We'll work on how to do word problems on logs, and then we'll work on the properties of logs, and then on Wednesday we'll how to solve logarithmic equations and exponential equations, and that will take care of the chapter. Okay. Hopefully everybody who's watching me today has taken exam 2, right? Do we have anybody here who has not taken exam 2 yet? Okay. Did everybody check their grades on Canvas? Okay. Just want to be sure you guys do that all the time. Now, before I show you today's work, somebody sent me a text message with one of the questions they struggled with the homework. Is that person there now? Let's see who's that person.
Yes, I'm here.
You're here? Okay. All right. Let me just show you. You have a calculator handy?
Yes,
all right.
sir.
The question was, all right, let me just show you how to do that problem. It's really easy. It's basically all calculator work. 2 to the power negative x over 24660. The question is, basically, this is the plutonium. Let me just show you what this graph is all about. This is about half-life. You have something that emits radiation. If it's this big, as time goes on, it starts shrinking because it loses weight due to the emission of radiation. So this one here tells you the year and how much left from that plutonium left. X is the year. Okay? And of course, the amount's going to decrease. That's why it's 2 to the negative. Means the amount's going to shrink more and more. So if they say how much will be left after 6,000 years, then X is 6,000. So you just replace X with 6,000. That's all you got to do. So the first thing you got to do is you got to divide negative 6,000 by 24,360. So you go to the calculator. You do negative 6,000, 6,000, then negative, divided by 24,360. And I got 2 to the power negative 0. Don't round here. So are you good, young man, so far? You understand what I did so far?
Yes, sir.
Okay, now all you got to do now is go to what? Press 2. How do you raise to a power on the calculator? X to the power y. Okay? And then negative what? 0.24630,542 negative equals. And I got 0.843, whatever they want you to do, and that's all you do. Does that answer your question?
See, on my calculator, it keep coming up error when I do it.
The reason is, okay, when do you get the error? From the beginning? Tell me when do you get an error?
After I divide, and then I put 2 in, then I raise to the power. Then
yeah. So what you do for the error, you press. I know how to take care of that. So on your calculator, don't put the negative yet. Do you have it with you now?
Okay. Don't put the negative. Okay.
Don't put the negative. Okay, watch me. Get your calculator ready. Press 0.24. Put all that number, then hit plus and minus. Okay, sorry. Start from scratch. Start from scratch. Clear your calculator. What kind of calculator do you have?
It's an app. It's a scientific
let me see
app.
if this one works. Okay, I don't know what kind that is, but I'll show you what it is. Start from scratch. Press 2 first. Do you see the key X to the power Y or Y to the power X somewhere? Or a little hat like this? Or X to the power Y or Y to the power X? Any of these letters?
Yeah, I see the first one. Yeah.
Okay, good. Do that. So press 2, then this one. Then press all of these numbers, then hit plus and minus and the equal sign.
Hold on, man.
And see if that works.
And you said plus and minus sign?
After you put 0.2 for that, then put plus or minus sign, then hit the equal sign. Will that work?
I'm just looking for the plus and minus sign.
It should be, or maybe negative. Don't do the subtraction sign. Subtraction is going to give you error. You see something like this,
No.
or maybe just negative like this by itself. I don't know what. As I said, I don't see the calculators in front of me. But just see if you have either this or this. Just keep looking for it.
Okay.
Did it work?
I'm gonna have to keep looking for it because I don't see that sign, the plus and minus sign.
So you try that; it's gonna work. If not, you're gonna get you another calculator. All right? You just go your. Do you have your what? Do you have a phone with you?
Yes.
Okay, let's use your phone calculator. Does your phone have scientific calculator when you rotate it or no?
No, it's just a regular the phone that comes the iPhone. Well, yes, it do. I guess yes.
Now let's do that one then. Okay, so let's do your calculator, your phone calculator.
Okay.
Okay, press 2 first, and then turn it around till you see one of these signs. Click on it, then put all this number, then plus or minus, and then hit the equal sign, and you should get this number 0. That means this how many kilograms are left after 6,000 years. Did it work?
Um, when I turn to the side, I don't see that sign X, Y, or the YX.
You don't see X to the Y or Y to the X on your phone?
Oh, okay. Oh, I see it now. I see it now. Sorry.
All right.
Well, I got like 1.186.
What did you get?
1.186.
No, then you know what that means? You didn't put the negative.
Okay, I'm gonna go and put it next there.
All right. Okay?
Yeah, I got it.
Okay, good. All right. You're in business. All right, class. So let's now go ahead and work today's lecture. So today we're going to work on word problems on logs and then work on properties of logs. Okay? First of all, not every log you can find the answer on the by mentally. So, for example, if I ask you to evaluate log 7, the base is 10 here because you didn't see the base. So, how many times would you multiply 10 to get 7? You cannot do. So, these, you have no choice but use a calculator for them. So, what I do is I go to my calculator here and I press 7 and then I hit the log and I get 0.845. So, most of so let's say I want to find log 89. See, the base is 10. How many times do you multiply 10 to get 89? I said, to do that. So really, the only way is to use a calculator. So I press 89 and log. I get 1.949. Okay? Now, does everybody know how to use a calculator to find the logs? Yes? Are we good?
Yes.
Okay. Now, there is another logs that we haven't learned yet. This one is called log The base is E. And remember, if you want to learn continuous interest, E is not a variable, it's a what? It's an irrational number, it's about 2.718, whatever. So anytime you see log with the base E, we call that in mathematics natural log, ln. The way we say it is natural log. So whenever you see ln, they don't show you the base, means the base is 2.718, whatever it is. So for example, if I ask you, says, how much is ln 91? What does that mean? You don't see the base. It means how many times you gotta multiply this by itself so many times to get 91. And that's gonna be impossible. There's no way in the world you can do that in your head. So that's why you gotta go to the calculator and you find that natural log. There is a key for ln on your calculator. So I press, for example, 91. Then I click on ln 0.511.
It's blurry. I don't know if it's just me, but I can't see anything. And now it shows. But it was been it's blurry. I don't know if it's just me or not.
How about it now?
Okay, that's good. Okay,
All right.
can I copy it?
Of
It's
course.
blurry again.
Yeah, okay, good. All right. So what does ln mean? Natural log. What does natural log means? The base is E. What is E? It's that irrational number 2.718, whatever. So we don't write log base E. Log base E is ln, natural log. And the values for ln, you can only find them on the calculator. You cannot do them in your head because you cannot multiply 2.718 by itself to get the number that you need. Does that make sense, class? So let's go to your calculator, see if you get for ln91, see if you get 4.51. If you did, means you're in business. Okay, as you're copying it, if you did not get 4.511, let me know. All right, can I erase the board now? Are we done?
Yes.
All right. So let's see, I gave you some word problems on logs. Okay? And they're really, really super easy, class. Okay? So I want to be sure you guys know how to solve them out. So one of the word problems I gave you on the test says this. The average annual cost of health insurance is characterized by this formula. Let's say G of X equals 1820 plus 165 ln X. 1650 ln X. Okay. G of X is what? The average cost, annual cost. How much it costs you a year to buy health insurance. X here is the year. And all of these word problems that I cite for you, I make it easier for you. I'm going to X equals 0 is the year 2000. X equals 1, 2001, and so on. Okay? So here's the question. So if I ask you, what is the annual average cost for the year 2020? So what would you do? If x equals 0 is 2000, 2020 means x equals 20. So all I gotta do here is just replace x with 20. So I'll have 1820 plus 1650 ln 20. So the answer to this will be my answer. But get your calculator ready. I want to show you how the calculator gives you that answer. So I go to my calculator here. First, I find ln 20. So 20 ln. Don't clear it. I got 2.9957. I keep it. Then that answer I multiply by 1650 times 1650 equal. I got 4942.958. Then I add 1820. So I got $6,762.96. Get around to meters hundreds here. So what does that mean? On an average, the healthcare insurance cost for a typical family in the United States per year, remember, is $6,760.96. It's about a little over $500 a month, according to this form. So how do you get the when you do homework on the word problem? You find ln first, then you multiply it by the number before it, and that result you add it to what? 1820. Are we good? Did everybody get that answer?
Yes.
Okay. So now what if I ask you, here's part B. Why don't you guys tell me the cost, average cost for the year 2050? Why don't you try it? Be sure everybody understands what you do here. All right, let's see if you got the answer right. So we're going to do 1820 plus 1650 ln 50 because the year 2050, right? So I'm going to do ln 50 first. So here we go. 50 ln times 1650 equals plus 1820. And I got 8,274 and 84 cents. So in the year 2050, the health insurance per year for a family in the United States on an average will be $8,274.84. Did everyone get that answer?
Yes.
Anybody? Okay. So the word problems for logarithmic functions are really easy. All you got to have a calculator. Okay. All right. Now, go ahead and copy it, class. We're going to spend the rest of the time learning the properties of logs. And that is very, very important. So that way you'll be able to understand what we're going to learn on Wednesday, where we learn how to solve log equations and exponential equation to finish the chapter. Okay? All right. So now at least you can do these problems with no problems, right? Okay, go ahead and copy this one here so I can teach you the next part of today's lecture. All right, can I erase the board, class? Okay, is everybody done copying? Okay. All right. So now it's the most important part. It's a different topic. Okay. The topic is properties of logs. These properties, they work for any base. Base E, base 10, base 2, base 3, it doesn't matter. And these are the ones you need to memorize. You cannot use notes for that. What is property number? Log two numbers, A times B, it'll be log A plus log B. Property two, log A, and remember I didn't put the base because they work for any base. A divided by B is log A minus log B. And the last property is log A to the power M is M log A. These work for any base. It's really easy to memorize. If log A times B, you just add. Log A over B, you subtract. And you have the exponent, you just make the exponent in the front. For example, let's say I want to find log 3 times 7. So it'll be what? It'll be log 3 plus log 7. Say if I want to find, let's say, log 8 over 9. I'm not putting the base because they work in the base. It'll be log 8 minus log 9. Let's say I want to find log 10 to the power 7. It'll be 7 log 10. I bring the power to the front. Okay? So these three properties, class, you must know them very well. You need to run it down because now we're going to be working on lots of problems regarding these properties. Okay? So these are the three properties going to help you do most of your homework assignment. Okay? So go ahead and copy them, please. And you can copy the examples as well. You're going to the video. Okay, you all finish copying? Okay, so let's see how we're gonna use these properties. And remember, they work for any base, that's why I'm not putting the base down. So here's a question. Let's say the question is gonna tell you expand. Expand means use the property, make it bigger, okay? Let's say I have log m to the 5 or to the 7. So how can I use the properties of logs to expand? First of all, these two numbers, m and r, are multiplied by each other. So I use property 1, which says it will be log the first plus log the second. Okay? Now I still can augment this, make it bigger, by using property 3. What does property 3 say? I can bring the exponent to the front. And there would be my answer. Okay, let's give you another example. Let's say I have log a to the 3rd, b to the 2nd, c to the 8th. How can I expand it? All these three letters are multiplied by each other. So it'd be log the 1st plus log the 2nd plus log the 3rd term. That's what the property 1 tells me. I can expand, so you use property 3 always at the end, where you bring the exponent to the front. That would be my answer. So what if I want to do log square root of x? One of the things about square root is you can write it as what? Square root of x and x to the power 1/2 is the same. Now you use the property 3 where you bring the exponent to the front. And that will be the answer. Okay? All right. I'm going to show you more about expanding logs in a minute, but I want you all to copy this and tell me if you have any questions.
It's in the freezer. I mean, in the milk freezer.
How's everybody doing so far? We good?
Yes.
All right, let's try more expansion. So what if I want to expand? Number 1, log w squared r to the 5th over p to the 3rd. I'm not going to put the base because they work for any base. So whenever you have quotient and division, you never use property 1 first. You use the one with the quotient. Quotient takes priority over the first rule. So according to property 2 would be log the numerator minus log the denominator. Okay? That's what property 2 says. Now, you cannot use the exponent. Why? Because I still have w and r multiplied by each other. There's property 1, which I have to add the log w squared plus log r to the 5. Whenever you have a single letter left, now you always use property 3, which is the exponent at the very end, where you bring the exponents to the front. Now you can say you're done. This is as much expansion as you can get. So if I was doing, let's say, I want to expand
Yo,
log
the refrigerator in the
x plus 1 over x minus 7. I don't have to do anything. I don't make it complicated. That's all you do. You log the numerator minus, that's it, you're done. That's all you write down. That's it. That'll be the final answer. Okay? All right, you can guys go ahead and copy this and let me know if you have any questions. Because after this, now we're going to work backwards. We're going to go from expanded forms to the original form. Now I'm going to give you a problem. You're going to make it what? A single log. That's what we're going to do next, but I want to be sure you guys copy this and ask questions if you have. Okay, let's now do the other way around. Now look what the question is going to say. Right? As a single log, and you really need this one the most. Everything I've taught you today is okay, but this is the most important. So what does this question mean? You're going to have the problem in expanded form, right, as single logs. Okay? So here's number one. Let's say I have 2 log x plus 7 log y. So how can I write this as log one term? Now I'm going to work backwards. The number in the front, I put it as an exponent. And then if I have addition, I got to go backwards on log. Addition, what I do, I multiply. And there goes my answer. So I made an expanded form, a single log, and that will be the answer. Does that make sense to everybody? Yes?
Yes.
So what if I have this here? 5 ln x minus 8 ln y. So I bring the number as an exponent. But now I have subtraction. So instead of multiplying them, what I do, I divide. And that would be my answer. So what did I do? I made an expanded form, a single log. What do y'all think?
Shouldn't that be an 8y to the power of 8 instead of 7?
But my bad. I was checking you out, see if you're awake.
Okay.
That's good. Good eye. You got better eyes than I do. I used to have good eyes. Got it? Go ahead and copy, class. We're going to keep practicing this. I'm going to keep giving you more examples because I really want to focus on this part because this is the part we're going to make it easy for me to teach you how to solve logarithmic equations on Wednesday. So Wednesday we'll finish the chapter here but if you don't know how to make single logs, you're not going to be able to understand my lecture on Wednesday. Okay? Guys, the semester is almost over. Today is May the 12th. I mean, April the 12th. May the 12th is we have 4 weeks to go. So hang in there. It's almost over. Right? I hope next year we'll go back to face-to-face lecture. I don't really like this virtual thing here. All right. Do you also need the board? Need the board, or you guys are done? Okay. All right. Let's do more single logs. So what if I have 3 log x plus 4 log y plus 7 log z? First, I bring the number as an exponent. Are these all additions? Therefore, I just multiply the letters. And that would be log 1 term, and I'm done. But mostly what we're gonna need next week, you're gonna be something like this here. Log x plus 7 plus log x plus 1. So what I need to, how do I make it log 1 term? I just multiply them by each other. Don't expand it, just leave it like this. That's all I want you to do, leave the answer as. See, this is most of the ones we're going to work next week to make single logs. Or if I have, let's say, ln x minus ln x plus 1, all I do, I just divide them. That's all I need to do to make it single log. Okay? And let's say I want to do 2 ln x minus 7 ln y. I made them as exponents first. And then I have subtraction, therefore I divide. If I have addition, I multiply, and that would be my answer. So go ahead and copy all of this, class. I'm going to let you try 2 problems to see if everybody understood this topic well, okay? And as you're copying it, let me know if you have any questions.
Recording. You gonna put it.
Okay, can I erase the board now? Yes? And I'm recording the lectures too, so you guys can watch it after maybe 2 hours. See it there too, okay? All right, so why don't you try this one? Question is, write as a single log. Same question I have on the board, okay? All right, let's see if you guys can do it for me. 4 log R minus 5 log W. Okay, try this one for me. I want to be sure you guys know how to write single logs. All right, so first I bring 4 as an exponent, and then I just divide. Did everybody get it right? Are we good? Yeah, let's see if you can try another one here. Okay, right as a single log. Okay, let's see if you get it right. First, I put it as an exponent. Since addition, all I gotta do is just multiply them. And that would be the answer. What do y'all think? Anybody can answer that. What do y'all think? Is this topic hard? Anybody has any questions so far?
No.
Okay, so now you know how to expand and you know how to write a single log. You know how to do word problems on logs, right? So you should be able to have the homework assignments. So the only assignment you cannot do now is how to solve exponential equations, how to solve logarithmic equations. So you must have calculators from now on, because I cannot teach you Wednesday class unless you have a calculator so we can finish the chapter. Is that clear, everybody? All right, I'm not going to start logarithmic equations because I don't want to confuse you. I think 2 topics is good enough for today. Okay? Anybody has any question? Are we good? Does anybody have any questions
Yes.
about the homework? Okay, so you guys, I'll see you on Wednesday. Just copy this and be sure you have a calculator ready because Wednesday is a very important class because it's a little harder topic on Wednesday than it is today. Okay, but I cannot teach you Wednesday class unless you know the basic properties of logarithms. Right? You guys have a good day and I'll see you on Wednesday.
You.
You're welcome.